In our second lesson for transformations, we're going to look at some of the rules that we have for transforming things on the coordinate plane. And again, we're going to look at all of our transformations. So we are going to do a couple more reflections. We'll do some rotations and we'll do some dilations as well as translations, our 4 biggies that you've studied before. So I have my video turned off because, again, I want to make sure that I'm not covering up any of the graphs that we're going to look at. So our first 2 that we're going to look at are reflecting over 2 lines. So our first line is y equals x. Now this line, if we graph it, is actually going straight through our 3rd quadrant and our 1st quadrant. And so we're graphing our line over this. Now we could absolutely count out our spaces, but it's a little harder to do since we have the diagonal line. And so our rule for this is all we're going to do is switch our x and our y coordinates. So every coordinate that we start with x, y is going to change. And this is kind of our rule that we can write out. We're going to just flip flop them. And those will become the x coordinate becomes the y coordinate and the y coordinate becomes the x coordinate. So let's list out our 2 values that we're starting with. So we had the point A, which our original coordinates are at -4, 1. And our original B and our coordinates were at -2, 3. And so if we perform our transformation, again, to find our new points, to find A prime, all we do is flip flop our x and our y. So that's going to become 1, -4 for our new point. Same thing for our new B, 3, -2. So let's plot them and see how we did. So new A or A prime at 1, -4. There's our A prime, and B prime at 3, -2. Connect the dots. And then you'll notice from our graphs, they do absolutely look straight across the line from each other. Okay, so very similarly, let's reflect over the line y equals -x. So I have a different graph on, or an additional graph on here, but we're going to do this with the same line just so we can see what the difference is between those reflections. So for this, our line y equals -x is actually going to go in the other direction, because if you think back to Algebra 1, when you have that negative in front of the x in your line equation, that means you have a negative slope. So instead of going up to the right, we're going up to the left as we draw that line of reflection. And so this is going to be very similar, except for that negative that we have. So not only are we going to flip our x and our y's, but we're also going to change the signs. So we're going to switch x versus y, and we're going to, oops, I spelled that wrong. There's an extra t in there. And we're going to change signs. So the point xy would become -y, -x. So again, let's start with our coordinates, apply that rule, and then see if that matches up with the graph. So original point, same thing as what we started before, because they're the same values. So A was at -4, 1. B is at -2, 3. And then to do our new point, so again, A prime and B prime, the result of our transformation, flip our coordinates and change the signs. So this is going to become -1, +4. Our B prime, -3, +2. And so let's graph this and see where it is. I'm going to change over to green though on this one because I don't want to confuse it with the red line. Okay, so my new A is at -1, +4. There's my new A prime. And my B prime is at -3, 2. Wait a second. So now the B is super close to the line, but on the other side, and same thing with the A. So we do have an overlap happening here, but same length segment, just flip-flopped. Okay, our last one is a little bit weird for reflection. We're going to reflect about the origin. So this is actually kind of like a 180-degree rotation like what we talked about last time. So we talked about point rotation or point symmetry, and this is going to be that in action on a graph. And you'll notice I'm using exactly the same points, exactly the same figures. So before we write out our rule, let's think about how this would work. So if you actually graph this out on a paper, or if you have the printed copy, If you don't, kind of turn your head upside down as you're watching the video. If you took B and you took the entire graph and twisted it around 180 degrees, that means B and A, which both started in the top left quadrant, would end up in the bottom right quadrant, but totally flipped around each other. And technically what this means is we're going to go, if we're reflecting in the origin, I want to kind of visualize, well, A is about this far away from the origin, so I want to go about that far away on the other side. So my A prime would actually be here, reflected straight across the origin. Same thing with B. So let me change colors. Let's go over to red. So I want to go straight through the origin and then keep going in the same direction, but the same amount of length. There's my B prime, and there's my new segment. So let's see what those coordinates actually ended up being on here. So again, original A was at -4, 1. Original B was at -2, 3. And so our transformed equation, our new A was at 4, -1. What happened? Look at your signs. Our new B is at 2, -3. What happened? When we reflect about the origin, all we do is change signs. So it's kind of almost a combination of, or the leftovers from the reflections we did before. So we reflect over the line y equals x, all we do is switch the x and the y. If we reflect over the line y equals -x, we switch the x and the y and we change the signs. And if we reflect over the origin, all we do is change the signs. So our rule is the point xy becomes the point -x, -y. And again, we figured this out without having any fancy rule to apply this to. So if you can graph this out, if you have a piece of graph paper or if you draw on your screen, then you can absolutely kind of map this out on your own without knowing the rule. But if you can remember the rules, it's going to be a whole lot more straightforward and you can get through the problems quicker. Alrighty, next set of problems, we need to do rotations. So there's a trick to these. So rather than memorizing the rules on these, what I memorize is what I have to do on each turn. So if I remember the direction that I'm going, where I started with, and what quadrant I'm going to end up in, that will help me predict my coordinates on my transformations. So for my first one, again, I'm using the same segment on here just so we can compare and contrast between the different transformations. If I'm going to rotate 90 degrees clockwise, think about old school clock, which way the hands turn. So clockwise is going around this way, 90 degrees. So that means if I'm starting in that second quadrant there with my points A and B, I'm going to be twisting around to be in the first quadrant. So I'll be in this quadrant here. So that means what are the signs going to be on all of my points? They're going to be all positive. But my A and my B aren't going to be perfectly flipped from each other. This is what happens. So this is how I remember my rotations. Every 90-degree rotation, I flip the X and the Y. And then I fix the signs for every turn. So for a 90-degree turn, again, let's start with our coordinates. So A was at -4, 1. B is at -2, 3. I made one 90-degree turn. So my new A flip-flop the 4 and the 1. And then if it's in the first quadrant, both of the coordinates have to be positive. For B, my new B flip-flop, so 3 comes first, 2 comes second. They're in the first quadrant, so both signs have to be positive. Alrighty, let's plot these and see if it looks right. So A prime would be at 4, 1. Excuse me, I didn't flip-flop those, did I? Pardon me. Flip-flop the order. I did it for the B, but I didn't do it for the A. So flip-flop for the A, 1, 4. 1, 4. Here's my A prime. B prime is now at 3, 2. So you'll notice if you actually took your paper and twisted it, it's going to look like it's ending up in that first quadrant. So I'm actually going to change your notes, and I'll make sure that the blank organizer is fixed. What we're going to do is we are going to change this to rotate 180 degrees counterclockwise, because I want to practice this rule. So again, we'll change this to 180 degrees counterclockwise, and I'll fix it on the organizer, so yours is actually going to have that on there already. Okay, here we go. So again, original points. A is at -4, 1. B is at -2, 3. Oops, I picked the wrong blue. That's okay. Alrighty, so 180 degrees counterclockwise. How many turns, how many 90-degree turns is that? So that's one 90-degree turn, second 90-degree turn. So we're technically doing a half turn. We're going through 2 quadrants. So 90 degrees, 180 degrees. That means I'm going to do 2 flips of my X and Y's. So I flip for the first 90-degree turn, and then I flip for the second 90-degree turn. So that means my X's and Y's are actually going to end up in exactly the same order, but the signs are going to change. So here we go. If I end up in the 4th quadrant, that means my X is going to be positive and my Y is going to be negative. So that's all I have to change. So A prime, I still have the 4, I still have the 1, because you flip and then flip back. The Y has to be negative. B prime, still have 2 and 3 in the same order, but the Y is the negative. So let's graph it and see what it looks like. So A is at 4, -1, or A prime rather. B prime is at 2, -3. Kind of looks like everything got twisted around on the graph, which is exactly what it should be. So let's go ahead and write out the rules that go with this. Again, I find it easier to, figure out, how many turns, how many 90-degree turns. I flip my X and Y for each turn, and then just fix the signs for whatever quadrant I end up in. Excuse me. So for the 90-degree rotation, what happened is we flipped our X and our Y, and we changed the sign on that X value. The Y value stayed positive when we moved it, but the X value changed from a -4 to a +4. For rotating counterclockwise, again, our value stayed exactly the same, but what happened to the signs? Signs were perfectly flipped. All righty. So here we go. Dilations. These are the ones I like the best because it doesn't take a whole lot of guesswork. For dilations, keep in mind, it's just a change of size. It's like when we were talking about similar triangles. So we just have to apply kind of our scale factor to each one of these figures, and then that will tell us what our new coordinates are. So if I'm going to dilate by a factor of 1/2, then all I'm going to do is multiply all my coordinates by 1/2. If I'm going to dilate by a factor of 2, I just multiply by 2. Or technically -2, because that's the dilation factor that they gave us. So again, I gave you new shapes because we want to see how these change in size. It's a little easier to do that with polygons. So let's start out with writing out our points. So the 3 points that we had on here, we had 1 point at 2, 4. We have 1 point at 6, 2, and we have another point at 6, 4. So all we're going to do to make our dilated coordinates, we are just going to multiply times 2. So the point 2, 4, excuse me, I'm going to 1/2. So 2, 4, divide each one by half. We're going to look at 1, 2. 6, 2 will turn into 3, 1. And 6, 4 will turn into 3, 2. So let's plot those and see what happens. So 1, 2, 3, 1, and 3, 2. we have a triangle that's half the size, dilated technically in towards that origin. So all we did was multiply our coordinates. So we had 1/2 x and 1/2 y. So let's do the same thing with the square that we have. Now I'm not gonna write all the, well, let's write all the coordinates. Okay, so original was 1, 1 at the bottom left corner. Then we had 1, 2 at the corner right above. Then we have 3, 1 at the bottom right corner, and we have 3, 2 at the top right corner. So if our dilation factor is -2, we're going to multiply every coordinate by -2. So -2 times x and -2 times y. That gives us -2, -2 on our first point, -2, -4 on our second point, -6, -1 on our third point. And now you're noticing why I gave you more space on that graph. -6, -2 on our last point. So let's graph those out. Unfortunately, I don't believe I have enough total space on here. So I am going to have my shape kind of going off the graph a little bit, but that's okay. So we have -2, -2. We have -2, -4. We have -6, -1. So let's see, my graph goes out to 5. I have to go one space over. I can actually use the guy on the other graph. And then we have negative, oops, what did I multiply incorrectly on those last 2 points? I forgot to multiply my y coordinates. Let's fix those. So we have a -6, -2, and a -6, -4. So 2 things happened here. We have a rectangle that's twice as big, but where did it get put? And we went on the other side of the graph, other side of the origin. So when we do dilate by a negative, it does end up flipping it around. Okay, one last rule, and then I do have some examples, but after we finish the rules, let's go ahead and, pause the video, take a quick stretch break before you do your practice for today. Okay, so let's do the last one, translations. So all these are shifting along the graph. And so if we are given a rule, again, we can just apply this to our coordinates and it'll tell us exactly where to graph things. So if we're going to translate up by 4, then all we're going to do is add 4 to which coordinate is going to control whether we go up or down. Now it's going to be the y's. So add 4 to the y coordinates. So our rule, if we're generalizing this, would be x and y plus 4. So all we have to do is just shift everything up 4 units. Let's just count that on the graph. So we go up 4, 1, 2, 3, 4. There's our A prime. From C, go up 4. He's sitting right on the x-axis. B, go up 4, 1, 2, oops, one more space, B prime. So just for one example, let's look at the coordinates on one of our points. So for example, A started out right below at -3, 1, and our new A ended up at -3, 3. Oops. -3, -1, and ended up at 3. So what did we do to the y coordinate? We just added 4. Alrighty, so last example, translate right 3 and flip over the x-axis. So we have 2 things that we need to do here. So we're actually combining transformations on this last one. So first, we're going to need to, let's actually write out a rule on this. If we translate to the right 3, is that moving x or y? It's moving the x, those go left to right. So we would want to take our x and add 3. But then they said flip over the x-axis. So thinking back to yesterday when we did our reflections across the x-axis and the y-axis. Well, x-axis is horizontal, which means I'm going to flip up to down, which means which coordinate do we need to change? We need to change our y coordinate. So that means our new rule would be x plus 3 and -y. So if I already know what the coordinates of my points are on this, I can just apply my rule and do everything in one fell swoop. So for this one, let's go ahead and write down all our points. So A is at -3, -1. B is at 1, -1. And I have to go down below my line. You should have margin on your paper. C is at, oops, sorry. C is at -2, -4. And so let's apply the rule that we came up with to do all of these. So we are going to go all the way to that second rule. So we're going to take each one of our x's and add 3. So our new a, -3 plus 3 gives us 0. Opposite of -1 is +1. New b, 1 plus 3 is 4. Opposite of -1, +1. C prime, -2 plus 3 is 1. Opposite of -4 is +4. So let's see if that worked. So our new a is at 0, 1. So there's a prime. Our new b is at 4, 1, b prime. And our new c is at 1, 4. Connect the dots. And there we go. It looks like we shifted the picture over and flipped it over the x-axis because it's now on the other side of the graph. Okay, now would be a good time to pause the video before I go through the application examples, but we have covered pretty much every single kind of rule that you could see for transformations. Now we just need to practice them.